Okay, you've handed us a truly fascinating document to deep dive into today. It's a request for information, an RFI,
Mhm.
put together for beloved organization dated June 17th, 2025. And the title, well, it gets right to the point. Databricks Streaming and Unstructured Data Processing Architecture.
And right from the start, this RFI signals something pretty significant. Beloved organization is looking for serious information from vendors.
Yeah, not just marketing fluff.
Exactly. They want details on best practices, specific tools, technical approaches,
Hmm.
and it's all for building a very particular kind of data architecture on Databricks.
And what kind of architecture is that? Seems like it's designed to handle two major, often tricky types of data,
Mm,
streaming data and unstructured data.
that's the core of it.
But the real kicker, I think, and where the complexity really starts to show, is that this data, it's coming from an incredibly wide array of sources.
Absolutely. The background section, section 2, confirms this is all part of a major data modernization effort. They want a platform that can support real-time analytics
Right, that's the streaming piece.
and also unlock value from data that doesn't fit neatly into rows and columns,
Yeah.
the unstructured stuff.
And the sheer scope of the sources they list. I mean, it spans traditional on-prem systems, modern cloud apps across Azure, AWS, and GCP, even IoT devices.
It tells you right away, this isn't just a simple upgrade. They're building a central hub for, well, for basically everything.
Okay, let's really get into the nitty-gritty of what data they're dealing with, because Section 3 lays out this extensive list, looking at the streaming side first.
Yeah, and this is where you immediately see that blend of old and new, right? They mention SSAS applications feeding data via change data capture, CDC.
Which is a common way to grab database changes almost as they happen.
Right, often pushing that into something like Kafka.
Yeah.
But they also list real-time APIs, direct database CDC pipelines, and even things like Databricks Autoloader.
Ah, autoloader or cloud files. That's super handy for streaming from cloud folders where files just land continuously without needing complex listing logic.
Precisely. But they don't stop there. They're talking about streaming coming in simultaneously from different clouds, Azure, AWS, and GCP,
Wow.
and then layering on top of that real-time feeds from IoT devices using protocols like MQTT, again, maybe funneling into Kafka.
Just coordinating speeds, formats, reliability across that many different pathways on the streaming side alone. That
It,
sounds like a serious challenge.
it really is. And then you pivot to the unstructured data sources in section 3.2. And this isn't just text files we're talking about.
No, definitely not.
They mentioned large file dumps from systems like SSAS, bulk data exports from APIs, could be CSV, could be JSON database logs in XML, or just plain text logs, folders full of binary files like images and PDFs.
Wait, hang on. So they're mixing like system logs and maybe financial report dumps with actual photos and documents, all landing in the same sort of ingestion flow.
That's exactly what it implies. And they even add multimedia audio and video files, potentially sitting in multi-cloud storage, plus file dumps straight from IoT devices.
Like sensor logs or maybe images from cameras on devices?
Could be anything, yeah. So unstructured here truly means everything from plain text right through to rich media.
So the core data challenge beloved organization is laying out here is, well, how do you build one unified architecture on Databricks that can ingest and process data arriving in real time from all those streaming sources,
Mhm.
while also tackling the ingestion, the cataloging, the processing of all these static but wildly varied unstructured files from an equally diverse set of places?
The sheer interoperability, the consistency needed across that whole spectrum.
Yeah, that's a major insight this RFI highlights.
And that complexity, it leads directly into their technical expectations in Section 4, which shows they really understand this needs specific approaches. They're not just asking if you can do it.
Now they're asking how you'd recommend doing it. Best practices.
Exactly. For the streaming data pipelines, Section 4.1, they want best practices. Things like, what are the right data schemas? Transformation techniques when your sources are this different? How do you handle potential schema drift?
Which is a huge issue in streaming. And critically, they ask about managing checkpoints and ensuring data consistency.
Checkpoints. Absolutely vital in streaming. Think of them like bookmarks, right?
Okay.
If your stream processing job stops for any reason, could be planned maintenance, could be a failure, the checkpoint tells the system exactly where it left off.
So it can just pick back up.
Exactly. It lets it resume processing without losing data, or, maybe just as bad, processing the same data twice. It helps achieve reliable, exactly once processing semantics.
Which sounds crucial for accuracy in real-time systems.
It's non-negotiable for robust streaming, really.
Then for the unstructured data pipelines, section 4.2, they outline expectations for handling binary and text data. And a key point here is their focus on metadata extraction and cataloging.
Yeah, that's important. If you're just dumping files into storage, how do you ever find the one you need later?
Good point.
Extracting metadata like the file path, modification time, size, maybe even basic content type, that's the first step to making all that unstructured data discoverable, usable.
And they explicitly call out needing integration with external services for processing complex types like images, audio, video.
Right. This shows they understand that while Databricks is the central platform, analyzing multimedia often requires specialized ML models or APIs that aren't, native to the core platform itself.
They even list examples: Azure Cognitive Services, AWS Recognition, GCP Vision APIs.
Which suggests a pattern they might be thinking of.
What kind of pattern?
Well, maybe ingest the file reference and some basic metadata into Delta Lake, which we'll get to, it's their preferred storage layer, and then trigger these external services from within Databricks, maybe via notebooks or workflows.
To actually process the complex media.
Exactly. And then link the results, the insights, back to the metadata record you stored in Delta Lake.
That makes sense, a kind of orchestrator role for Databricks.
Precisely. And speaking of Delta Lake and other bits, the RFI grounds all this by listing the technologies they're already using in Section 5. Gives vendors a clear picture of the environment.
Right. They list Databricks itself leaning towards Azure Databricks. They note Delta Lake as their storage foundation.
Which is a very strong signal.
How so?
Well, using Delta Lake suggests they prioritize reliability, schema enforcement, ACD transactions, features you usually associate with databases, right?
Yeah.
But applied to their data lake. This is crucial when you're dealing with the kind of complexity and potential messiness from all those sources they described. They want data lake benefits, scalability, cost, but without sacrificing quality and reliability.
Okay, that makes sense. They also list Kafka for stream ingestion, the major cloud storage services Azure Blob, AWS S3, GCP storage.
Showing that multi-cloud footprint again.
REST endpoints for API data, and MQTT for IoT. So those are the building blocks.
Those are the pieces vendors need to build upon.
And to make these technical expectations even clearer, Section 6 includes example code snippets, which is actually a great touch in an RFI.
Yeah, it really helps. The streaming data ingestion example, 6.1, it shows reading from sources using Spark's structured streaming. You see read stream being used with formats like Kafka and cloud files.
Confirming they're thinking about Databricks' native canonities for these continuous flows.
And what's really insightful, I think, is how the example shows merging streams from different sources, Kafka and cloud files, using the .union operation before writing it all out to Delta Lake. Now, that simple .union in code, that represents a huge challenge in practice.
How so?
Harmonizing schemas, data quality, maybe event timing, from wildly different inputs into a single consistent Delta table, that's not trivial.
Right. And the write operation to Delta Lake, it explicitly includes the checkpoint location and the output path.
Reinforcing again how important fault tolerance and reliable state management are for these continuous jobs. They're baking it into the example.
The unstructured data ingestion example in 6.2 is also revealing. It shows reading binary files using cloud files with the binary file format option, and immediately demonstrates how you can extract useful metadata path, modification time, length, useful stuff.
Yeah, while it shows reading text files simply with .text, it's that explicit strategy for images, audio, and video that stands out again.
Storing references in Delta Lake.
Right. And then using external cloud services, Azure Cognitive Services, AWS Recognition, what are orchestrated from Databricks notebooks. It provides a really clear blueprint for how they plan to handle that specialized, unstructured data processing.
Okay, so given this really detailed technical picture, what does Beloved organization actually want from the vendors responding to this RFI? What's the ask in Section 7?
Right, Section 7 spells out the specific information they need. Vendors have to demonstrate experience with Databricks for both streaming and unstructured data. That's key.
Makes sense.
They want a clear, step-by-step architectural approach, ideally with diagrams, showing exactly how a vendor would tackle this whole challenge.
And here's where it gets really interesting, I thought. They ask for specific examples of real-world, large-scale, real-time projects the vendors have actually implemented.
Yeah, that's crucial. Proof.
And they even cite companies like Uber, Netflix, Tesla, Spotify as examples of the scale and the demanding nature of the environments they want vendors to have experience in.
That tells you a lot, doesn't it?
Yeah.
They're clearly looking for partners who've operated in the big leagues.
Yeah.
People who have solved these problems under pressure.
Absolutely.
Yeah.
What else do they ask for?
Recommendations on tools and frameworks may be beyond the basics they already listed. Detailed coding examples demonstrating specific capabilities, and, crucially, deployment and operational best practices.
Because building it is one thing.
Running it reliably, efficiently, at scale, that's a whole other challenge.
Okay. And finally, Section 9, how will they judge these responses? The evaluation criteria.
Well, the primary criteria focus on the relevance of the proposed solutions, naturally, but also, very importantly, demonstrable experience with similar multi-source, multi-cloud Databricks implementations.
So track record matters a lot.
Definitely. Technical depth and clarity in the responses are expected, of course, but the core of the evaluation seems to really center on proving the ability to effectively handle both the structured streaming and the unstructured data ingestion challenges,
Right, the two main themes.
specifically at scale. This just confirms again that unifying these disparate data types and sources reliably is the central hurdle they need partners to show they've cleared before.
So looking back at the whole document then, this RFI is, well, it's more than just a list of requirements, isn't it?
Oh, absolutely. It's really a snapshot of the challenges involved in building a modern, comprehensive data platform today, a really ambitious one.
Yeah, it shows how success now means bridging legacy systems with multi-cloud, with new sources like IoT, handling incredibly diverse data types.
And doing it all reliably at significant scale,
Mm.
often using platforms like Databricks and key tech like Delta Lake and Kafka as the foundation.
It really lays bare the complexity, but also the ambition, I suppose, of trying to unify an entire organization's data landscape.
It does. It's a solid blueprint of a complex data modernization effort. It really focuses on those core challenges: ingestion, consistency, making all these different kinds of data actually usable.
Okay, so here's a thought for you, the listener, to maybe mull over as you wrap up your own deep dive into this material with us. Beloved Organization is pulling data from everything from those old SSAS databases right through to brand new IoT cameras potentially spitting out video files. If you had to pick just one thing, what do you think is the single most difficult technical challenge in making all of that wildly different data usable and reliable within one unified platform like Databricks?